So we're going to find what is the exact Z-score for an ACT score of 21. So remember, student A had an ACT score of 21 and the national average was 20.8. And if you remember, a Z-score that is 0 means that they're at the mean. So we know that their Z-score for student A is going to be about 0. But it's not exactly 0 because it's not exactly 20.8. It's actually 21. And it's a little above the mean, so it's going to be slightly positive, okay? So here's the Z formula. Z equals X. X is the raw score. The raw score is what the actual value is before you transform it into a Z-score. You subtract off its mean, mu, and divide by standard deviation, sigma. So we're going to fill it in. So 21 was the student's raw score. We're subtracting off the mean of 20.8. We're going to divide by the standard deviation of 4.8. So you just simply fill in the formula. Then by order of operations, we want to do the top first. And we're going to do 21 minus 20.8, and that's 0.2. And then we're going to divide by the 4.8, and we're going to get 0.04. So a person who has an ACT score of 21 has a Z-score of 0.04. I'm going to go over how to interpret some Z-scores, and I'll give you some examples. So here we have a Z-score of 0, and that means the person scored exactly at the mean. Because if you take a value and subtract off the mean and it equals 0, that means the value had to be exactly the same as the mean. So that means that person scored at the average. A Z-score of 1 means the person scored 1 standard deviation above the mean. So we have a positive Z-score, so that means they scored above the mean, and it has a value of 1, so that means it's 1 standard deviation above the mean. A Z-score of -2 means the person scored 2 standard deviations below the mean. So we have a negative Z-score, which means that they scored below the mean, and we have a value of 2. So the person scored 2 standard deviations below the mean. If we have a Z-score of 5, the person scored 5 standard deviations above the mean. So again, we have a positive positive Z-score, and it's a value of 5, so the person scored 5 standard deviations above the mean. And this could be a possible outlier, because remember before, our rule of thumbs for this class is if a value is more than 3 standard deviations from the mean, then we are going to call it an outlier. Now it might be different for different classes or in different situations about the outlier rule, but just for this class we're going to have the kind of rule of thumb, kind of a guideline, that if it's more than 3 standard deviations from the mean, then it's an outlier. And Z-scores tell you how many standard deviations you are from the mean. So if you have 5 as your Z-score, then that means you're 5 standard deviations from the mean, and to be exact, above the mean. So this could be a possible outlier. So Z-scores can be helpful in determining what outliers are, or which ones are outliers. Now remember, Z-scores allow you to compare people on separate scales that measure the same construct. So with the ACT and SAT example, we have the same kind of construct. They're both measuring either IQ or readiness for college. So that's the same construct. They're measuring the same thing, but they're on different scales. Okay? So another example might be test grades. You might want to compare your test grades in one class to your test grades in another class. Now it's not exactly like per se the same construct, but you know, they're comparable. You can see how well you did relatively to the rest of the class, to the average. So if you have a z-score of 1 in your statistics class, then you did 1 standard deviation above the average, so you're doing, you know, pretty well. But if you had a z-score of -2 in, say, your history class, then you're really below the mean. And you're doing kind of poorly. So you can see that you're doing poorly in history, and you can see that you're doing good in stats. So you can say, I'm doing better in stats than I am in history. And these two classes can have different means and standard deviations because that's just how classes are sometimes. You have different mean scores depending on how hard the tests are. So you can compare your scores in one class to another one if you have the mean standard deviation. But also you can determine how far a person is from the mean. So you don't have to compare two different scales. So if you just want to know how well you did in statistics and you're not really comparing it to your history class, then you can just compare how well you did in your statistics class compared to the average. And that's helpful on its own. You know, and sometimes it's more helpful than just the raw scores. So, for example, with ACT scores, you know, they're just kind of arbitrary numbers and they don't really follow, you know, the typical grading scale of 1 to 100 like you do on other tests in school. It doesn't go on a percentage. So to be a little bit more helpful, you can calculate your z-score on the ACT and you can see how you did relatively to the average. And that's way more helpful than saying you got a 18 or whatever. Now, you might kind of have a sense of how good an 18 is because you kind of looked at what the average is. But in essence, you're really just kind of intuitively making a z-score in your head because you're comparing it to the average that you know. So if you had a 23, you know, you kind of already know that your ACT score is good. But if you calculate the z-score, then you kind of know like exactly how good it was.